This is Dr. Jagannadha Rao, Head of Mathematics and Applied Science, Kalinga University. Today, Module 1, Regression Analysis and its properties of regression analysis and assumptions of regression analysis and its uses, I will discuss in this first module. So, what is regression analysis? So, linear regression. In regression analysis, it is a predictive analysis also called, and linear regression is one of the easiest and most popular machine learning algorithm. Nowadays, artificial intelligence, machine learning, these are all popularized tools. So one of the best tool in machine learning is by using regression analysis we will discuss. It is a statistical method that is used for predictive analysis. Linear regression makes predictions for continuous as well as the real or numerical variables such as, for example, in a company, sales and salary as well as age and product price, etc. So linear regression algorithm shows the linear relationship between a dependent variable and one or more independent variables, hence called as linear regression. Now, in linear regression, it is a set of a statistical process. It is a set of statistical process for estimating the relationships between a dependent variable and one or more independent variable. As earlier I said, these independent variables are also called as the predictors or covariates or futures. So, in predictive analytics uses the variety of statistical techniques such as in modeling as well as in data modeling and data mining to predict the future probabilities and trends based on historical data. This goes beyond reporting what has happened to create best estimates for what will happen. Some common applications of this predictive analytics include fraud detection. And nowadays, if we are using a credit card or any debit card, if transactions are higher, then automatically they will get the bank people will get the alert and they will give the call and they will ask whether this transaction is yours or someone else are doing. So these are the main important features of this predictive analytics and risk assessment, marketing and operations. So also by using this predictive analysis, we can understand what are the inventory levels and understand the supply and demand, and companies might use regression analysis to understand why customer service calls are dropped in the last year even for the past month, and predict what sales will look like in the next 6 months. And there are types of regression analysis: simple and multiple regression, and the second one is linear and non-linear regression, partial and total regression. What is a simple linear regression? It is used to estimate the relationship between two quantitative variables. One is dependent and another is independent. In multiple linear regression, also known as simply multiple regression, is a statistical technique that uses several explanatory variables to predict the outcome of a response variable, means one or more independent variables. Previous in simple only one independent variable, in multiple we will use one or more independent variables. Linear regression relates to two variables with straight line, and non-linear regression relates with variables using curve. Non-linear regression, it is a very powerful tool for analyzing the scientific data, especially if you need a transform data to fit a linear regression. We will use this. A total regression. What is a total regression? Total regression analysis is one which is made to study the effect of all the important variables of one another. For example, when the effect of advertising expenditure and income of the people, price of the goods on the volume of sales are measured, it is a case of total regression. A partial regression analysis, it is one of which is made to study the effect of one or two relevant variables we will study. Remaining variables we will not consider. Out of 10 independent variables, only we will study 4 to 5 or 2 to 3 relevant variables of that particular project. So partial regression plot attempts to show the effect of adding another variable to a model that already has one or more independent variables. Next, the properties of regression analysis. Regression coefficients are independent of change of origin but not the scale. And second one is the regression of correlation is geometric mean between the regression coefficients, means r is equal to plus or minus of under root byx and bxy. Byx is nothing but regression coefficient of y on x. Similarly, bxy in the sense regression coefficient of x on y. So regression line intersect at average values of mean values of x and y. If you plot this regression line, x and y mean values, the line will intersect. Both regression coefficient will have the same algebraic sign. If byx is positive means bxy is also a positive, and byx is negative in the sense bxy is also negative. If one of the regression coefficient is more than 1, the other must be less than 1. Now, the regression equation. So, in a simple regression, y is equal to ax plus b. We will study in our lower classes also. Y is equal to ax plus b is a straight line equation. In plus some epsilon. Epsilon is a error. While every project have some minor errors, that error we will take it as an epsilon. So, y is equal to ax plus b plus epsilon, where y is nothing but predicting the y value for a given x value, and epsilon is a random error. It is also called as a residual, and m is the slope and y-intercept b are given. Now, what are the assumptions of linear regression? Actually, linear regression have a lot of assumptions, but some major assumptions I will discuss here. First one is linearity. Second one is no multicollinearity, and mean of residuals is 0, and homoscedasticity, and residuals normality. The x variable and variables are uncorrelated. First, linearity, the first point. The relationship between x variable and y variable shall be linear. So, linear means by sometimes using log or exponential or other functions, we can convert the non-linear into a linear model. Then we will plot the graphs. There should be no autocorrelation in the data. So, autocorrelation in the sense, one of the critical assumptions of this multiple linear regression is that there should not be autocorrelation in the data. When the residuals are dependent on each other, there is an autocorrelation. This factor is visible in the case of stock prices. If stock price of one product is decreasing, automatically it's relevant to all products prices will becomes lower. So, the stock prices, when the price of a stock is dependent on its previous one. Plotting the variables on a graph like a scatter plot allows you to check for autocorrelations if any. And another way to verify the existence of autocorrelation is Dorbin-Watson test. It is the best test to check whether the given data has an autocorrelation or not. If data is not having the autocorrelation, we can use this regression analysis. Now, no multicollinearity. So, multicollinearity is when two independent variables are strongly correlated. Y is equal to a plus bx plus cy, right? This a, b, c are variables, right? And x and y are values. So, multicollinearity, when two independent variables are strongly correlated, then we say that it is a multicollinearity. Using correlation graph or by using heat map, we can check the correlation between the variables. How to fix it is by using simply out of two variables which are strongly correlated and remove any one from the model. For example, x and y are in the independent, both are relating to each other, highly correlated. If effect of x automatically affects on y, then any one of these variables we can remove and we can use the regression analysis. So, this is the concept of no multicollinearity, and mean of residuals is 0. Residual of an observed value is the difference between observed value and estimated value. So one regression line, if you plot, the actual values will be surrounding of that line. Exactly every point will not lie on the line. So the difference between that line point and this your actual point difference is called as the residual. So here the mean of these residuals, if you calculate the mean for these residual values, then it must be 0. Here for example, some dots values are there and red dots are on the line and some another dots are on the surrounding of that line. So the mean, if you calculate for this, it should be 0. Homoscedasticity. So homo means same and scedasticity means variance. So it means it must be same variance. If the variance in the residual error is constant regardless of the dependent variable x, then it is homoscedastic. And dependent variable have more same variance across the range of the values. Next, residuals normality. So normality in next module I will discuss elaborately. Here only I will discuss about the outline. So residuals should have normally distributed. Normal distribution in the sense it is a bell-shaped, symmetrical bell-shaped. Symmetrical in the sense the mean, median, mode at the center peak of the curve, and all three are equal in the normal distribution. So elaborately we will discuss in the upcoming module. Normal distribution is also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean. Means left side of the portion and right side of the portion exactly it is like a mirror image. Data near the mean are more frequent in occurrence that are far from the mean. What I said at center of the curve, bell-shaped curve. So in the bell shape it is a peak at mean at center of this peak, and this left side, that peak point the frequency is more, and if you are traveling towards the left side the frequency will becomes, data frequency will becomes lower. Similarly, if we travel towards the right, the data frequency will becomes lower. In a normal distribution will be a bell-shaped curve. Properties of normal distribution. Here light properties we will discuss. It is a continuous probability distribution, takes into account continuous variables like height, weight, time, IQ score. If you observe but kid height every year normally it will changes up to 14 years, 15 years. So weight, it is a common change in a human body. Every month or every year the weight will may increase or decrease. So IQ scores, time, etc. These are all the examples of this continuous variables. Perfectly symmetrical and bell-shaped. It is divided into two equal halves with mean at the center. And main important feature is it is having a unimodal, means it has only one mode and the mean, median mode are equal. And asymptotic to the baseline means the curve has a tendency to touch the x-axis but never touches the axis. In this bell-shaped curve, this left tile and this right tile, it looks like touching the baseline, but it never touches the baseline. The range, first of all, the normal curve extends to infinity, that is from negative infinity to positive infinity. The total area under the curve, normal curve is 1. The total area under this normal curve is 1. And x variables and residuals are uncorrelated. So last sixth property, as I said, the x variables and this is residuals are uncorrelated. Means the correlation between x, independent variable, and the residual should be very small or uncorrelated. Now coming to uses of regression analysis. For predictive analytics, in beginning only I said what are the predictive analytics and all. So forecasting future opportunities and risks is the most prominent application of regression analysis in business. Now most of the banks as well as in the companies, they are using this regression analysis and they are predicting the risk by using the previous historical data. They will study and they will give what are the problems in future and how to solve that problems by using this predictive analytics they will implement. And demand analysis, for instance, predicts the number of items which a consumer will probably purchase. In stores, if you observe big shopping malls, so what are the products frequently moving, they will keep all those products in a corner place. Why? Because the customer will go and touch that product. What are the products are not moving quickly, that they will keep at the nearby billing desk or at the entrance of the desk, right? So why? Because they need to increase the sales of that particular product. They want to get more revenue for the store. So however, demand is not the only dependent variable when it comes to the business. And regression analysis can go far beyond the forecasting impact on direct revenue. For example, insurance companies heavily rely on regression analysis to estimate the credit standing of policyholders and a possible number of claims in a given time period. Now, another important use is new insights. Over a time, businesses have gathered a large volume of unorganized data that has the potential to yield a valuable insights. So earlier, nowadays everything is computerized. Data is storing in a computer by using SAP, ABAP, by using SAP modules. So, however, this data is useless without proper analysis. If I have a huge data, but without analyzing that, without proper utilizing of the data, it is useless. So the regression analysis techniques can find a relationship between different variables by uncovering patterns that were previously unnoticed. For example, analysis of data from point of sales system and purchase accounts may highlight market patterns like increase in demand or decrease in demand or average, right, on certain days of a week or at certain times of the year. If we observe in certain markets, online digital markets, right, in this Amazon, Flipkart, they will provide discounts, weekend sale, or in the middle of the week or at the festival time. So they want to rise their sales, they want to grab the market. So you can maintain an optimal stock and personnel before a spike in demand arises by acknowledging these issues. So next, operation, not only insights of this, and operational efficiencies also it will provide. Regression models can also be used to optimize business processes. Example, in a call center, we can analyze the relationship between wait times of a callers and number of complaints. So now if we call, now every company is giving to this corporate people for this discussions and as well as for their business purposes. Call center people, they will respond, they know the product details and they will explain the product and everything. So they can analyze what are the relationship between this waiting time of the customer. If customer, if they are giving more time for waiting, then customer will not show interest on the product. So the data driven decision making and supporting decisions, the businesses today are overloaded with the data of finances, operations and customer purchases. Increasingly, executives are now learning on data analytics to make informed businesses decisions that have statistical significance, thus eliminating the intuition to and gut feel. Regression analysis can bring a scientific angle of the management of any businesses by reducing the tremendous amount of raw data into actionable information. And also by using this, we can use for correcting the errors also. The regression analysis not only great leading in empirical support for management decisions, but also for identifying the errors in judgment. For example, for this correcting errors, in festival season, the sales will be high. So the maybe company manager may think extending the working hours, right? For extending the working hours, in the sense they need to pay the extra amount to the employees as well as extra benefits to the employees, and what are the sales in that particular time period. All these things, it will gives the prediction and it will correct the error, whether it required to extend the time hours or not. Next, so another important analysis in the regression is logistic regression. So we have discussed simple, linear and multiple, as well as total regression, partial regression, and similarly another important regression analysis is logistic regression analysis. So what is the linear and in this logistic difference is, logistic regression is a method used to predict a dependent variable given a set of independent variables such that a dependent variable is a categorical variable. For example, male, female, yes, no, okay, no, true, false, like that. So here response variable, binary variables holding values like either 0, 1, yes, no, or A, B or C. For example, for admission in a particular university. So the cutoff they given as a 6.5 or above CGPA. So either 6.5 above, then S, 6.5 below, then no. It is only categorized into two categories. 6.5 above will becomes S and 6.5 below becomes no. So there are two categories, yes or no, or true or false, 0 and 1. So this is the logistic regression, another important regression analysis. And logistic regression is a method to predict the dependent variable on a given set of independent variables such that the dependent variable is the categorical variable. So next, what is the differences between this linear regression and logistic regression? In linear regression, one continuous dependent variable based on values of the independent variable. In logistic regression, to predict the categorical dependent variable based on values of the independent variable. Here dependent variable is a categorical variable. In linear regression, the dependent variable is a continuous variable. And least squares estimation, as well as in this maximum likelihood estimation. And this linear regression will give the straight line, and this logistic regression will give the curve, sigmoid. It is also called as the sigmoid curve. And this relationship is a linear relation. In logistic regression, linear relation is not necessary to, or not it is a mandatory to linear relation. Thank you.